me like why is it different than the name value pair class?
Well, um, well, here, let me draw a picture of what we're trying to accomplish here. I don't want to spend too much time on like very basic programming concepts. So, like the fact that you're trying to look at this class
Yeah.
and let me move my little thing here. That should let me do it. And look at this class and you're wondering why individual lines are different. I mean, they're accomplishing different things. So if I draw a picture here, um, everybody can see my screen. Let's assume that's a yes.
Yes.
All right, so we have the concept of this thing called the variable environment. All right, and our variable environment's job is to hold a bunch of name value pairs. So for instance, if I just kind of show what problem we're trying to solve here, I might have a my age is equal to 15. I might have another variable here, maybe called magic number is equal to 121, something like that. So a variable environment holds a collection of name value pairs. Now, the way we're managing our name value pairs is by using another object. We created an object here called name value pair, where name value pair can hold on to, so we can have a name value pair that has my age is equal to 15. And then we can have another name value pair that has magic number equal to 121. So our variable environment holds a collection of instances of name value pairs. Is that more readable? That's more readable. Something like that. So we have a single instance of variable environment we're creating, and inside of that, we are adding name value pairs to it. So we have a name value pair for my age equals 15. We have a name value pair for magic number equals 121. So the reason these two classes are different is this one holds an array list of these guys, where these guys hold two pieces of information, a string for the name and an int for the value. So these are just general Java objects, nothing special about them.
So we know it mean here add variable here, right?
Well, this guy right here is going to have a couple of abilities. He's going to have an ability called that we were writing for our homework called, what was it called? Add variable.
Yeah.
And then another one for get value.
Yeah.
So he has these abilities right now to put a variable into his collection. So if I called add variable and I passed it val equals 7, I would then get a new one of these where val was equal to 7 added to that collection. That's what the add variable function does. Takes in two pieces of information, creates a variable out of it, and adds it to the collection of name value pairs. But from what I'm hearing from you is if you're looking at this class right here and you're looking at this class and you're wondering why individual lines look different, that's like a beginner programming question. So then you need to go back and look at some like introductory to object-oriented programming tutorials or something like that to understand what those differences are.
No, like in the couple of the syntax is like when we create the object under the variable environment called yeah, this dot the variables equals to new array list.
Yeah.
So are we creating the object here called the variable?
Yeah, well, we're adding a value to this variables. So the variables is the name of a variable.
Okay.
Of type array list. So this guy called the variables, if we go back to my picture here, in my code, this dude is named, he manages the variables. That's what his job is. He manages that variable called the variables, which is a collection of name value pairs. So every instance of variable environment, like we're looking at right here, this is a variable environment. His job is to manage this guy, which is an array list. So we can generically say this is a collection of name value pairs. The fact that I'm using an array list to hold this collection is insignificant. We just chose array list. We could have chose a linked list. We could have chosen a normal array and just made it super big and kept track of how many things we had in there. So we just arbitrarily said, well, array lists allow us to have arbitrary size collections. So we'll just choose that as our collection type. But it's managing this thing called the variables, which is going to be a collection of these name value pairs. And that's what this guy's job is, to manage those. And then for our homework, we were to implement these two methods. So here, let's just implement them real quick, and then we'll see them being used. So for add variable, we're taking in a name and a value, and we should be creating an instance of name value pair and then adding it to our collection. So we would say this dot the variables dot add new name value pair, passing it name and passing it value. So if we go to name value pair here, name value pairs constructor takes in a string and it takes in an int, and it builds me an instance of one of these guys, a name value pair. And what did I do with it? I took the name that was passed in here, the value that was passed in here, created a new instance of name value pair, and added it to my collection of name value pairs called the variables.
The variable dot add. Yeah.
So then out here in driver now, I can go ahead and, so here's our add variable. So this is what I said should work. So we're adding a variable named A, set it equal to 5, a variable named B, set it equal to 7. Then we're telling that guy to, go ahead and display itself. So now we should see our variable environment having two variables in it, A and B. And there's our A and B in that variable environment. And then the second part of the assignment was to write, we should take in the name of a variable. So for instance, if I took in B, it should give me the value of B. And the value of B right now is a 7. So that's what this guy does. He should return the integer associated with the value of this variable name. So he's going to go through all the elements of his array list. So we'll say for name value pair MVP in this dot the variables if MVP dot get name dot equals the name we're looking for. So if the current variable I'm looking at, the current name value pair's name I'm looking at is equal to the name we're searching for, then I'll go ahead and return get value of that guy. And return makes the function immediately end, so this guy will end. If for some reason I get through all of my values here and I never find my variable, you know, there's lots of things we could do here. I could, what I did last time is I just returned to -1 so we wouldn't have errors here. But maybe the appropriate thing to do would be to do something like a throw new runtime exception variable not found, something like that. Is it not called runtime exception? Is it all one word like that? Yeah. So this gives us a kind of an error message while we're running it if we ask for a variable that doesn't exist. And that's not even part of the assignment really. That this is more like, what do we do if we didn't find it? Right now, we could assume that all the name value pairs we're looking for, we find. So if I'm looking for A, it gives me the value of A. If I'm looking for the value of B, it gives me the value of B. But this method does say you have to return an integer. So you can either just return a -1 as a, like, oh, well, we're not going to call this incorrectly, so we'll just assume it always works. Or this is probably the safer thing to just throw an exception that just prints out, hey, the variable you were searching for was not found. Something like that. We can decide to tighten that up or whatever later, but for right now, that's probably a reasonable enough thing to do. So now I should be able to say, show me the value for A, show me the value for B. So that gives me the 5 and 7 by looking those up using my get value method. And then similarly, if I want to see my error message, I can look up a variable named C, which we know we did not store in our variable environment, and it's not going to find this, so I'll get my exception. So exception, variable not found, just, that doesn't really give us much to work off of with that, but we're at least getting an error message now that if we didn't find our variable. So something along those lines should have been the result for the homework. So this should not have been, let's see, what did we write? We wrote just these two things. So this was the homework assignment. So these should have been relatively easy, but hopefully pointed out showed you where your current competency levels are in programming. So if you found this difficult, that's fine. That just means you have remedial programming skills and you need to go fix that. You got to go look at tutorials or give yourself a crash course or something like that. But these should have been pretty easy to just pump out. All right, so questions about...
In our homework assignment, we're not having the exception, right? We need to return a negative value, -1.
Yes, I think.
With the exception, you don't have to.
Yeah.
And I mean, so if we're just talking through this, I don't care if you return the -1, that's fine. That's not the end of the world. The problem with doing this, like the possible logical issue with doing this is, since all of our name value pairs hold a, so here, let me just take this out here. I'll just show you the example. If I store C is equal to -1, that's legal. I can store the value -1 associated with C. So now I'll get a -1 from that. But if I also look up a variable named D, I'll get a -1 from this. So I'll have that false sense of security that both of them gave me -1 as the answer, where C actually is equal to -1, but D didn't exist. So it just returned a -1. So now I don't know which of these is true. So having it throw an exception allows us to possibly handle this. A runtime exception technically gives us the, when I wrote it like this with a runtime exception, this gives us an exception that doesn't require us to deal with it someplace else. If instead I make this guy a normal exception, so I throw a new exception, variable not found, I then have to advertise up here that this guy throws an exception. Fine, no harm, no foul. But what that changes then is over here in driver, it doesn't like what I have written here because it says, oh, every single time you call get value, it potentially throws an exception. So now I would have to do a try to do all this stuff. And then catch an exception-y. And I can do something in here. Couldn't find the variable, need to fix that. Something like that. So by me making it a normal exception rather than a runtime exception, it now, and then I have to advertise this guy throws an exception. That then means when I go and use it out here, I have to try to do these things because I'm accepting, it's like self-policing code. I'm accepting that this particular function If I pass it a variable that does not exist in my environment, it's not going to be able to find it. And I can't just assume I'll get a value, because right here I asked for a variable D, and D is not found. So if I come back into here, I already took out the -1 there. So now instead of it giving me a -1 and a -1 here, I'll get a 5, a 7, a -1, and then I'll get an exception. 5, 7, -1, and there's my exception that I was able to potentially handle myself. All I did is print something out, but I could have handled it directly myself if I wanted to. Other questions? Okay, so now that we have a fairly simple variable environment for holding our for storing variables, if we go back to our slides here, we were talking about the job of a parser last time. So we should read in some syntax that looks the way we want it to read, and then convert it into convert it into something else that we maybe looks like the objects we're currently writing. So we talked about kind of the different flavors of programming languages. Then we started talking about variables specifically, and that was off this idea of how do human beings solve problems. This guy, memory, asking questions, repetition. So to build the most simplistic programming language that's, let's say, possible, we have to have facilities for remembering stuff. And right now we have a variable environment, which is going to help us remember stuff. So now we can associate the language with that for defining those variables. We can then ask questions. So we're going to have to implement if statements and things like that into our language, and then repetition. But we're starting off with just this memory stuff. We want to have in our language, we want to have the ability to remember things. Okay. So we keep coming down through here. So there's our variables. We started talking about the idea of historical data structures. So arrays, linked lists, stacks, queues, trees, graphs. So these are just named data structures that you maybe would have had in a undergraduate data structures course. But the reality is that a data structure is just, in the object-oriented world, is just an object that organizes our data in a certain way so that we can use it. So with that in mind, we would look at this and say, my name value pair here is a data structure. This is a data structure. We've named name value pair. It requires two pieces of information. So it manages two pieces of information. It manages the name of a variable, and then it also manages the value associated with that variable. And right now, the only kind of values we know how to hold are ints. And we'll change that eventually, but for right now, we're keeping it as simple as possible. So all of our values are always integers in our language right now. So we're going to have a language that allows us to do math initially. All right. So when we build a name value pair, we'll pass in those two pieces of information. We'll set up those two pieces of information. And then we just gave ourselves some getters and stuff to retrieve and potentially set the values of these private fields in our name value pair. But it would be fair for us to say that this is a data structure that we invented that knows how to store a string associated with an integer and gives us some facilities for working with those. So it's not an overly fancy data structure, doesn't change the way the world spins or anything like that, but it's still a data structure. It's a structure for holding data. Similarly, we have another data structure we've created here called a variable environment. And this variable environment manages a collection of name value pairs. So even though this guy happens to be an array list, I know I've said this several times today, but even though it happens to be an array list, we just chose that as our collection type. If you're doing stuff around the house and you're cleaning up some stuff, you can you can get a box to throw things into, you can get a garbage bag to throw things into, you can get a let's just leave it at that. You have two different collection types that you can use to throw stuff into, but they both are just holding collections of things. So we chose to use an array list to hold a bunch of name value pairs. And that's what this data structure does. This data structure manages this array list. He allows us to add things to it, and he lets us get the value of things that are already in it. So kind of search through it for things that already exist in there. All right, so that's what our variable environment does. It's another data structure. So our connection there is this idea that data structures are like the name of an entire class in an undergraduate computer science program. But typically in that class, we're introduced to our classical data structures. But a data structure are things that we invent all the time. So I would almost argue that any time that we create a new object type, it's a data structure for some specialized purpose. Okay, so that's the concept of data structures here. So for us, we created this variable environment that now knows how to, we can load name value pairs into it, and then we can retrieve the value of a name value pair from it. Okay, so now with that in mind, and then here's our little picture of what that guy looked like. So we might say, what's next? So now that we know how to store name value pairs, and we know how to retrieve the value associated with a name value pair, we can associate a syntax with our language that allows us to programmatically create name value pairs in our new language and uses our data structures to make it real. All right, so we're going to invent a syntax for creating variables in our language. And what I mean by that is if we look at this in the traditional sense, let's just assume that we were inventing the C programming language. All right, so we know in the C programming language, we would do something like int a is equal to 5, something like that. That would be the line of code, the line of C syntax we would write with the intention. So this has the intention of creating a new variable named A and associating the value 5 with it. All right, that's what this syntax right here has the intention of doing. All right, now we can go ahead and we can define our syntax to be identical to this if we wanted to. Or we can invent our own syntax for these things if we wanted to call it like, you know, maybe in our language, we decide to say, we want to remember A as 5, something like that. We could choose to have our syntax look like that. Remember A as 5. So that's kind of saying the same thing as A is equal to 5. Remember A as 5. So this is a little bit more English-like, a little bit more wordy, but it's still something that we could operate off of for our programming language. I purposely want to have a syntax that's different than C, so we get this feeling that we are inventing something new. So maybe this type of thing is called a remember statement. And we have our variable name. So maybe the syntax for this guy is remember var name as var value. That might be the generic syntax for this guy. Now, we could also, this goes back to something we wrote. Let's see, where did I have it? Strongly typed versus loosely typed. loosely typed versus strongly typed languages. So if we were in, so this is in C. In a language like Python, we would just say A is equal to 5, Python. And that would have the same implication of what we were trying to do, but it wouldn't allow us to define the kind of value that we're going to be storing in there. So we can decide which makes the most sense for us is, do we want to remember a variable name associated with the value, or do we want to remember a variable name that is associated with a type of value? So we could alternatively write this like, remember var name as var value. Let's see. We could maybe even write it like this, as var type having var value, something like that. So our syntax might look like, if we were to try to say A is equal to 5, we could say, remember A as 5. Similarly, we could say, remember A as int having 5. So this would be our syntax. We're just inventing this. I just came up with this today, right? We just decided that, oh, in our programming language, when we want to remember a variable, we're going to call that a remember statement. And a remember statement is going to have a variable name associated with it and potentially a type, and then the value that's there. All right, but the actual syntax for it looks like this. So there's a lot of pieces, a lot of fluff here that we might want to parse out. You know, similarly, we want to keep it looking, if we want to keep it looking similar to C, we could do something like remember A equal 5, something like that, or even remember int A equal 5. So we can kind of make it like a superset of C, where we're specifically saying, look, I'm going to remember something here. And what am I going to remember? We just tack on normal C syntax, where we have the type, the value, the variable name, and then equals the value. All right. So do we have a preference for what we want our syntax to look like for our language? I definitely don't want it to look identical to C. That's going to be for the purpose of learning for what we're doing here. But out of these, I don't care which we go with. This is a decision that we can make as a class. What do we want when we're writing code in our language? What do we want our syntax to look like? When we create a variable, what do we want it to look like? Or do you have another suggestion other than these? Do you have any takers for preference?
Yeah, I think remember int A is equal to 5 is the better option.
Yeah, that is Java related, I think.
One. Which one do you like? You like this one? This one?
No, with
A
the int type, defining the type, like the second remember int A is equal to 5. Yeah.
Okay, but putting the word remember in front of it. Okay, so we're going to still have a different than Java or C syntax by having the word remember be in front of it, but then inside we'll still have a familiar syntax from Java or C or whatever. But our whole syntax for remembering something will be remember the type, the name equals the value. That's what our remember statements will look like. Okay, so now that's when we have to start defining our language. So I'm just going to create a slide here called the language. And we can come up with a name for our language later on. So you can start thinking about that if you want. Doesn't matter what you call it, but like, we have C, we have C++, we have Java, we have C#. What's the name of our language? That's something we should come up with. But in any case, for our language, The very first type of statement we're going to be working with here is a remember statement. So we'll have remember, and then I'll just put placeholders here. So var type, var name equals var value. All right. Now I'm going to go ahead and let's assume that all of our lines are separated by semicolons. I think that's going to give us some flexibility for our parser here relatively soon, since we want to focus on the parser and not on other things. The reason I say that is if you think about a language like Python that doesn't have individual lines or individual statements separated by these sort of special symbol, writing an interpreter for that relies on each element being on a completely separate line, and Python has different levels of indentation that you have to take into consideration, and all those things are fine. There's nothing wrong with that. We can certainly go that direction, but we might just decide that in our language, everything is separated by semicolons, so we can deal with each of those little pods in and of them, in and of themselves. But even having said that, once we get to things like loops, that have the body of the loop, we might have some interesting connections, because for instance, if we think about a for loop in Java, we can say, or here, let's assume we just have this repeat loop that we're going to invent. So we're going to repeat something 5 times. Let's just say that's our case. Now inside this, we might say, remember 6 is equal, or a is equal to 6. Int a is equal to 6, something like that. And then we have another remember int b is equal to 5. And then we end our repeat. So maybe we're thinking about syntax for Java here. We'd have an opening and closing curly brace. But we don't actually have, you know, typically in Java, we wouldn't actually have a semicolon there. But let's assume we put a semicolon here, and we're reading in this string from a file or something like that to actually run our program. If we're separating on semicolons, it's going to actually give us everything here, because the first semicolon it finds is this guy right here, as opposed to this semicolon here, where maybe if we are parsing this whole thing, it might be nice if we can get this whole thing as a chunk and then say, okay, now that I have this chunk, now I want to go through and I say, how many times are we doing it? This many times. Great. Opening curly brace, closing curly brace. So inside there, we're going to have our collection of things that should happen as part of this loop. Okay, so we don't want our parser to be too difficult to run. So we might say, okay, well, if these guys are inside of a loop, maybe we separate them with commas, something like that. So it's do this, then do something else. But these guys are part of what we're doing inside of this repeat loop, as opposed to a standalone, you know, maybe that before that repeat loop, I have something like, remember int c is equal to 10. And that's standalone, so I have a semicolon. And then in here, I have a repeat some number of times. Now, how many times will we have it? Maybe we just say C times, with the idea that we're going to resolve C to 10. Well, when we used a remember statement here, we had a semicolon at the end. When we used a remember statement in here inside the body of our repeat, we used commas to separate them, to keep it distinguished between when each statement was done. Because we want to read in the single statement and say, I want to decide what does that statement mean in our program. Then we read in the next statement. That whole collection is our next statement. And then we process that collection in and of itself. All right, so these are things that we can, these are decisions we make as a language developer ahead of time, and this dictates the complexity of our parser. It also dictates what our, you know, when a programmer is writing something in our language, what their experience is like. So these decisions have consequences. So if we're going to try to write this as a fairly easy parser, we might decide that each individual statement is separated by a semicolon like this. But maybe within a statement, if we have multiple things that occur, we replace the semicolons with commas for multiple statements being dealt with. So let's just kind of go along with that mindset, but understand these are decisions we're making as human beings, saying that this is what we want our language to look like. And when we say we want our language to look like something, that comes with the consequence of maybe being easier, harder, whatever, weirder to have to implement the parser and the interpreter behind the scenes. All right, but we haven't written this kind of thing yet, so we don't need to worry about this quite yet. So right now we're writing single statements that end in a semicolon that is remember something in our language. Now, before we can really do that, well, let's go ahead and write the first part of our parser. So we're going to create a parser, and the job of a parser let's go back to this. Is to convert human syntax into more usable objects for the interpreter. So for example, if we have something that looks like this, maybe we turn that into an object called name value pair. So I'm going to remember something. What am I going to remember? Well, actually, maybe we have an intermediate step before name value pair. Maybe we have a remember object with 3 fields. We have a type, we have a name, and we have a value. All right, so we have a remember object that keeps track of those 3 fields. And this is associated with a remember statement. So maybe even call this a remember statement object. Well, I would put dashes in there, maybe remember statement. I like that. So maybe we decide we're going to have a remember statement object that is going to keep track of 3 things, a type, a name, and a value. Now, as a human being, we look at this string. I'm going to go ahead and just put double quotes around it just to really emphasize that this guy is a string. Okay, so this guy's a string. I recognize the kind of thing we're dealing with here when I see remember beforehand. So as I start processing through this string, and I get up to the first space, let's say. So everything before that first space is the kind of statement that I'm dealing with here. We hope that we have enough information there to uniquely determine what kind of thing we're dealing with there. So since we find a remember there, which is great, that then tells us, we are going to be creating a remember statement. That's the kind of object I need. Now, what do I need to build a remember statement? I'm going to need 3 fields, a type, a name, and a value. So before we go any further, let's go and create our remember statement. Actually, just before I forget here, let me shut this down. So I'm going to go into our code here. I'm going to create a new object. This is going to be a class. It's going to be called a remember statement. Okay. And we've decided that remember statements keep track of 3 pieces of information: a private string name, a private string type, and a private. Now, for value, this is going to be a little bit cryptic for us, because we're kind of foreshadowing here and saying that, well, we're going to obviously be able to hold other types other than integers in our language, even though right now with our name value pair, we only know how to hold integers. So I'm going to go ahead and say string, the value I'm going to store as a string for right now. This is kind of coming with knowledge that Java is what I usually refer to as a string-based language, which means if I can store something as a string, I can move it to other kinds of values pretty easily. All right, so I'm going to decide to store all my values in the kind of the pre-interpreter state as strings. But if I were to use this kind of statement in code, if the type was an int, I would have to convert this value to an integer before I could do stuff with it. But just for storage purposes, we'll store them as a name, a type, and a value, all as strings to keep them convenient. So now we have our constructor for this guy. So our constructor is going to take in a string name, a string type, and a string value. So it'll take in those three pieces of information, and we'll set this dot name equal to name, this dot type equal to type, this dot value equal to value. Okay, so we're setting those things. Now for our remember statement, we want to be able to get these things, but remember, this is an intermediate step. So let me show you kind of what we're building here. If I draw a picture of the inner workings of our program, we're going to have our human code. This is our syntax. All right, so we're going to write stuff in a syntax that we're defining for our language. That's going to then go through a parser. So the parser turns syntax into intermediate objects. I'll color code this. All right. Then we have our interpreter turns intermediate objects into output in our language based on logic. Something like that. So this is the step. As a human being, we want to write our code this way. Ultimately, we want to have an interpreter that makes it run our program on the screen. All right, so the interpreter is the ultimate goal. The parser lives between these two steps. So we're going to convert between our human syntax into something that's maybe going to be a little bit easier for an interpreter to work with. So in our example here, if we're just going to really drive this home, we're going to have a remember statement. So remember A is equal to 7. Let's see, remember int A equals 7, like this. So that's what that line of code might look like there. But what we're going to turn that into is a remember statement holding A, int, and 7. So we're going to parse out the type, the variable name, and the value here, and then use those three pieces to create an instance of a remember statement built using those three pieces of information. So now I have a Java object version of this string that I can then use for doing logical stuff inside of my interpreter. All right, does that make sense? The job the parser is doing, it's converting between this into something that is an actual object-based remember statement. And that's what we're currently writing right here. I'm saying I'm going to need a data structure, an object, capable of holding these three pieces of information. I'm going to need to be able to get those three pieces of information. So in Eclipse, you can right click you can go to source, generate getters and setters. And I just want to give myself a getter for all of these. I don't need to set them in here because these are purely informational. This is just the intermediate step that my human syntax gets converted to so that my interpreter can work with them more easily. So that just gives me these 3 functions. You could have written them yourself too, just a little bit quicker to get name, get type, get value. All right, so I'm just creating a little object that allows me to, once I have my 3 little pieces here, I can turn them into an object that I can then ask for those 3 pieces of information. That's going to make my life when I'm writing the interpreter easier. Okay, so now we're going to create our parser. Well, the start of our parser. Our kind of our go-to move here as we write our language will always be decide on the new kind of syntax our language should support, add that ability to our parser with any objects that need to be done there, and then add the way to execute that to our interpreter. So we're going to be constantly saying, oh, we want to add a new feature to our language. Great. So what's the human syntax for that feature? Then how do we parse that into some objects that our interpreter is then going to use? And then how does that feature actually get implemented? That's going to be our cycle. This entire 8 weeks is anytime we add something, we invent the syntax, we parse it, then we add to the interpreter the change for it. All right, so now we'll go ahead and I'll create my parser. We'll call this guy our parser. Now the reality is for my language, I only need a single parser. So I could actually write this parser using a bunch of static methods. So I'm just kind of thinking about kind of what's good programming practice for this, because the parser is like a single tool, right? I can take my syntax here, so maybe this isn't a file, and I just dump it into my parser. And my parser produces a collection of statements to be processed by the interpreter. Now, with that in mind, this parser only needs to exist once. I don't need to create 50 different instances of parser. So I'm going to make this parser, if it follows, if you have ever heard of something called the design pattern, it's going to follow what's called the factory design pattern. Relatively unimportant, but I'm not going to have to create instances of my parser. It's just going to work. All right, and you could certainly make an argument for it to go a different direction, but this is the way I'm gonna rate it here. So our parser is going to manage a collection of. Let's just start going down it. I might change my mind on how we're going to implement this, but I think we're okay here. So I'm going to say we're going to have a static. For right now, I'm not going to have any variables here. You're going to see we're going to have to add some stuff here relatively soon. But I'm going to go ahead and I'm going to have a static. Let's keep it void for right now. Parse. And this guy will take in a string as a parameter. And his job is to parse this string into language objects. So in our initial case, the only thing it's going to be able to do initially is turn remember syntax into a remember statement. That's what we're ultimately trying to do initially, because that's the only thing our language knows how to do right now. You know, we're in the very early stages of our programming language. We're just trying to give it that first qualification for our programming language and saying, languages need to be able to remember things. Great. All right, so the first thing the parse is going to be able to do is it's going to be able to read something like that. And actually what I'm going to do is to keep this fairly separated, I'm going to call this guy parse remember. All right, and then I'm going to have another function in here just called parse. I'll have it take in a string for right now, but soon we're going to have it take in a file name. All right, so what I want to do is I want to look at the first part of my string S. So I'm going to call this guy parse statement for right now. All right, so my statements, the only statement that exists in my language right now is remember A, or remember int A equals 5, something like that. That's the only kind of statement that lives in my language right now. Okay, and because I probably split my thing up on semicolons, I don't have to worry about dealing with it. So I'm going to have a string that's going to come into this guy that looks like this. All right, because that's the only kind of statement that currently exists in our language. We'll add more. I've already foreshadowed a repeat one that we'll probably add for our like first kind of loop. But for right now, we know this is the only kind of statement. We want to turn this into something else. So first thing I need to do is I need to get the individual pieces of this, that is the stuff separated by spaces, because that's our, if I look at this, I have remember, I have int, I have A, I have equals, I have 5. Now, we are interested in this first part. This tells us what kind of statement we're dealing with. And then since it's a remember statement, we're interested in this part, and this part. All right, so I'm going to start off by getting our parts. I'm going to say string array, I'll call this the parts, is equal to s dot split on space. So I'll go ahead and split it on spaces. And then I'll go, and this assumes that there's only one space between these things. I'm pretty sure if I split it on more than one space, it won't do what I want it to do. Here, let's just test that real quick. Just put it after this stuff. So if I have a string array parts is equal to remember int, I'll put some extra spaces in here. A is equal to 5 dot split on a space. I expect to have 1, 2, 3, 4, 5 parts here. I don't know how it's going to treat. I think it will treat each of these spaces as an extra divider. It'll have empty strings. So I want the length of this to be 5. I want parts length to be 1, 2, 3, 4, 5, and I think it's going to be bigger than that. Let's see if it gives us a 5. Yeah, it gives us a 10 because of all these extra spaces. I think there's something else I can split it on instead of space. I think I could split it on white space. Character dot, is it just as the character set? Java split white space. I thought it's a character set. Oh, they're not using built-in. Oh, that's true. I could, so that's actually a better way of doing this. So I can say, here, I'll just copy that. Let me make sure it does what it does first. It gives me a 5. Yeah, that gives me a 5. All right, so technically the split function, and you'll see what I mean here. If I say the empty string dot split, notice how this guy takes something called a regex. This is a regular expression. All right, so in regular expressions, I'm saying to, this says split on this regular expression, which is a space, at least one space, possibly more. So that's what I'm saying right here, is rather than saying split on a single space, which is what that would be, I'm saying split on one or more spaces. But this is using the syntax for something called regular expression. So for us right now, this will do what we needed to do. That way, when somebody writes their line of code, they can use various amounts of spacing. You know, if we're looking at Java, I can do something like int a is equal to 5. I can also say int, then put a bunch of spaces, b, then put a bunch more spaces, equal 7, like that. And that's also perfectly legal in Java. So I'm taking out the variability here of all these extra spaces. So I'm saying I'm going to split my line on one or more spaces between tokens. So this will just make our life a little easier. We won't have to worry about it. So now, even though I have all these extra spaces in here, it's still only going to get me the 5 actual pieces of information that I care about. And I'll show you what I mean by that. So now if I say, show me parts at bucket 0, this should just be that remember part. And there's remember. If I say parts at bucket 1, that should be the int part. Parts at bucket 2 should be the A part. Parts at bucket 3 should be the equal part. Parts at bucket 4 should be the 5. There's our 5. Okay, so this is getting us those different pieces. All right, so I'm going to go ahead and steal that little regular expression there so we can bring it back into our parser. So I'm going to go ahead and split on that. That will get me my parts. And then I'll go ahead and ask the question. If.
Excuse me, what do you call the double slash s plus? Is the name anything?
This?
Yeah.
Well, that's what I was just talking about. This is the regular expression for one or more spaces.
Okay. Yeah. Regular expression.
All right. So if the parts at bucket 0 dot equals remember. Okay, so if I'm looking at one of those guys, I want to go ahead and parse on remember. Now, actually, what I can do here is I can say, well, parse remember takes in 3 pieces of information: string type, string name, string value. So I'm going to go ahead and I'm going to say, I'm going to call parser dot parse remember, and I'll pass it the type, which is the parts at bucket 1. I'll pass it the name, which is the parts at bucket 2. And I'll pass it the value, which is the parts at bucket 4. So when I want to parse remember, I know that this is assuming they're giving us accurate syntax, which we will assume for this. We're not going to do syntax checking. We don't have enough time in terms of weeks to like write a full-fledged language that checks syntax. So we're just going to make sure if you give it good syntax, it works. If you give it bad syntax, it's going to crash in some sort of horrible way. So since I've recognized that the statement I'm currently parsing is a remember statement, that is the very first part of it, when I split it on white space, is the word remember, I'll go ahead and then call my parse remember function, this guy up here, which is going to take these three pieces, the type, the name, and the value, and it will then turn that into a remember statement. So up here, I'll say remember statement, rs is equal to a new remember statement. And if we look at remember statement here, it wants me to give it the name, the type, the value. You know what? I'm actually going to just change this to type, then name dot value, because that's kind of the order in which we write it. I don't have to change anything down here. Just for the way I call it, let's just keep it consistent. So int A5, int B7, for example. Okay. So when I build a remember statement, I need to pass it those three pieces of information. So those three pieces of information, I'm actually already passing into parse remember. They came from parse statement. So I'll just pass it my type, my name, and my value. Okay. And for right now, I'm going to have parse remember return a remember statement. So what I'll do down here is I'll just go ahead and say return remember statement. I'm sorry, RS. Return RS. So parse this guy, takes in three pieces of information, builds me the object, and then returns that object. I might change the way that's happening here in a few minutes, but for right now, we're going to say that's its job. That's what it does. Okay, so when somebody passes something to my parse statement will split it, determine what kind of something it is. Right now, it can only be one kind of something because we only know how to handle remember statements. So I'll go ahead and call parse remember, and this guy is just going to get the result from that. Let me actually think about this. When I think about what my parser should ultimately do, my parser should have a collection of statements associated with it, because that's what our program is in our language. It's a collection of statements. So if I go back and we kind of talk about that. So a program is a collection of statements, where a statement is a collection of parts of that statement. Okay, specific kinds of parts. So what we're going to do here is we're actually going to create an object-oriented model for this. So to draw you a picture of that, I'm going to say we're going to have this generic thing at the top called a statement. And then from that, we're going to have some different kinds of statements. Remember statements. This here, I'll actually just put a space in there. So that's one of our kinds of statements that we have from that. All right. So we're going to say that a statement itself just has a name. But a remember statement has a name, a type, a value, and let's see, actually, let's call this guy a statement type for his name. So the statement type for this guy would be remember statement or remember, something like that, because this guy is also going to have a type, a name, and a value, where the name of this is the variable name associated with the remember. So I'm going to create this hierarchy for objects here. That way we can ultimately have a collection of statements, where statements are one of many kinds of statements. So I'm going to come in here and I'm going to create a new class called statement. And a statement is going to have a statement. So a protected string statement type, because we're going to be using inheritance here. That's why we make it protected. And we'll have our constructor for a statement. Yeah, this is fine. So we'll have our constructor for our statement take in a string statement type. And we'll say this dot statement type is equal to statement type. Right now, it's all a statement will know how to do. Okay. We can actually, if I want a statement to be able to display itself, I can go ahead and we'll say public string to string. That way it'll work with system.out.println. And this guy will take in nothing, and he's going to return statement concatenated with this dot statement type. Something like that. That's what a statement will do initially. So where I just build it with its statement type, and but then it knows how to display itself as a statement type. So this guy would say statement, remember statement, something like that, if it's that kind of statement. Then my remember statement, this guy right here, he would extend statement. So instead of him extending the default, which is object, we're going to have him extend statement. So ultimately, inside of my parser, I can have a collection of statements, where some of those statements are remember statements, some of them are repeat statements, some of them are other kinds of statements, even though right now they're all going to be remember statements, because that's all our language knows how to do. All right, so we're just building a simple object-oriented model here, where we're going to say we have this top level object that does very, very, very little, and it's called statement. And then all of our other kinds of statements will be one of these guys. So I kind of mentioned that maybe we'll have a repeat statement for part of our repetition. So we'll have another statement that's also a statement, but he's going to be a different kind of statement, but he could still go in a collection of statements. All right, so a remember statement extends statement here. And what we'll go ahead and do is we're going to call upon our parents constructor and pass this guy a remember statement as its statement type. So the first thing that our constructor for remember statement does is he lets his parent know that, oh, our type of statement is called a remember statement. And then we'll go ahead and fill in the other pieces of information here for what's specific to a remember statement. All right, so now, go back to our parser. Our remember statement is ultimately going to, well, our parse remember is ultimately going to give us a remember statement built out of these three pieces of information. And then what we're doing right now is we are returning that guy. We could either return it and deal with it in here. So, and I'll go ahead and do that. So I'm going to say that a parser. So we're going to have a static array list of statements called the list of statements. And this will be a new array list of statements. And I need to import java.util array list. All right, so now our parser class is going to have an array list called the list of statements, because when we think about a computer program, ultimately we're going to have a list of statements that we're going to be working with. Okay, where each of those statements has meaning that we're going to process when we are, that our interpreter will ultimately go and process. All right, so drawing a picture of this, what's a program? A program is a collection of statements. All right, so when we think about our actual program, we're going to have a collection of statements where each statement gets handled, let's say in order, for right now, gets handled in order so that our program can ultimately run. So if we think about this like a Java program, you might say maybe this is int A, this is int B, and this is system.out.println A plus B, something like that. Okay, so we have a statement that gets executed, then another statement, then another statement. But when we go and parse this program, we're going to have to turn the strings into objects that can then be interpreted. And that's what our parser is doing. So our parser is going to maintain this collection of statements that makes up our program. And that's what I'm doing right here. I'm saying I'm going to create an array list of statements called the list of statements. And every single time I parse a statement, I'm going to go ahead and say the list of statements dot add, and this guy's expecting me to add a statement to it. And remember statement is a statement. It's one of those guys here. I'll kick this down a line so you can see the whole thing on the screen. So if I go back to my remember statement, you see that a remember statement is a special kind of statement. So he qualifies as a statement. So right here, when I call parser.parse remember here takes in my 3 pieces of information for a remember statement. It builds that remember statement, and then it returns that remember statement. So this whole thing right here boils down to an instance of a remember statement, which then is getting added to my list of statements. So this is the collection of statements for my program. Okay. So now if I want to go and test this, I'll get rid of all these things for right now. I'll say string s is equal to, this, some line of code in our language. And then I'll go ahead and say parser dot parse statement. I'll pass it S, and then I'll say parser dot display. I haven't written it yet, but I'm about to go write it. And that guy is going to go through and parse, or go through and show me all the statements it parsed. So if I go into my parser, I'll go ahead and write display, static, void, display, and he's going to say for statement S in the list of statements. S, so I'll do a system.out.println S, which we'll call his toString method, which should, for this case, just say remember statement, because that's what we said here for statement. So it's going to say statement, remember statement. And if I really want to add to that under remember statement, I can give him his own toString, public string toString. And what he'll do is he'll say return super.toString concatenated with, maybe I kick it down a line and then put a tab in. And then I say this dot type, this dot name equals this dot value. So that means if it's a remember statement, when we say system.out.println, it'll call this version of toString, which will first call his parents toString, which will say statement remember statement. And then we'll kick it down a line and put a tab in, and then it'll say the type, the name, and the value for that. So it would be like, int a equals 5, something like that. That'll prove that we have parsed it correctly. So if we go back to driver here, we're going to, here's the line we're parsing. So we don't have a full program yet. We just know how to parse individual statements right now. And then we'll go ahead, what's this guy? Super keyword is how to refer to your parent from within yourself. So if I'm inside of remember statement and I say super dot, or up here I'm saying super, I'm calling my parent's constructor. My parent here is statement, because that's what I'm extending here. So statement has his own toString method that just prints or returns statement followed by the statement type. And the constructor for statement takes in a single statement type. So back here in remember statement, when I call my parent's constructor, I say, oh, I'm a remember statement, by the way. And in fact, I'll even put spaces there, it's fine. And then he differentiates himself by saying, I have a name, a type, and a value. That's what makes me a remember statement. And then down here in toString, I'll go ahead and say, well, I'll go ahead and let my parent speak by saying, get his version of toString. And then I'll say carriage return and then a tab. Actually don't need that space. And then I'll put in my type, name, and value. So now when we go and run this, I am parsing a single statement, this guy, which should create a remember statement, a single remember statement, and add it to my list of statements. Parser.display should go through everything that's in my list of statements, which right now is just going to be one thing, and tell each one of those to display itself using system.out.println on an object automatically calls that object's toString method. That's what we're ultimately doing. That's why we wrote these things inside of this method called toString. All right, so we'll run this. What row? String S. That's that. Parse. Oh, it's because it's looking for a lowercase r and remember. There we go. So we have a statement, remember statement, int, I got to put a space there, equals 5. So this is my remember statement. Like that. And there's our int a equals 5. All right, so now in the ideal world, we want to be able to read stuff in from a file that has our syntax in it, right? All right, so what I mean by that is in my program here, I want to maybe create a new file. And maybe we call this guy, we'll put him in our source directory. That'll be okay. We'll call this guy input dot, let's see, we got to come up with a name for our language here. Let's call it, I don't know, what do we want to call it? Anybody have a good name for our language?
I think spider.
Spider?
Yeah, spider.
Right. Is that done like, is it literally spelled .spider like that, or is it going to be like
SPYDER.
SPYDER, spider like that? Okay, so the name of our, so our file type will be a spider file. So instead of input.java, this will be an input.spider. All right, so there's that's going to be the file we create here. And then inside of that file, we'll put a couple of strings. There it is. So there's our remember int 5, and we'll have our remember int b7, for example. All right, so that is our file that we're going to deal with right now. So that's what our program looks like. It's going to have just 2 statements in it right now because we have a very limited vocabulary for what our program can do. So now what we want to do is we want to read in from this file. And I think I have one of these things probably has an example, because you have to do something kind of funky with files in. That's what I want. Okay. All right, so inside of parser, we're going to go ahead and we're going to have a function called parse. So I already have a parse statement. Now I'm going to have a function static void parse. And this guy's going to take in a string file name. That's the file that we're going to parse. I'm going to paste this code in here. Oh, okay, so parse is going to take in the name of a file. We're going to go ahead and use our scanner to open up that file. This guy can throw a file not found exception. So I'll just go ahead and wrap this in a try. Catch. I'll do like a system.err.println file not found, something like that. Okay, so what Parser will do is it'll take in the name of a file. We'll go ahead and create a tool for reading in from that file. And then just to prove that it's working for right now, we'll say while input.hasNext, we'll do a system.out.println. Input.next. So we'll prove that we could read in from that file. All right, and we named our file input.spider. So we'll go back out to driver here. So we'll go ahead and say parser.parse input.spider. That's the name of our file. And right now there won't be anything to display. But parse should take in the name of this file. And it should open up a scanner to read from that and then print out every line that's in that file. So we should get the contents of our file. So remember int a equals 5, remember int b equals 7. Now actually notice here that it's bringing them in one token at a time. So actually what I want to do is I think I want to say next line. Next line will bring in the entire line. So there's this line and there's this line. Okay, so that's the contents of our file right now being read in one line at a time. Now we decided that we wanted to separate our lines by semicolons. All right, so I actually don't want to read it in one line at a time. I want to get the entire file. And I don't think there's a way for Scanner to give me the entire file. So we're going to just build up a string. Next. So we'll go ahead and say string file contents. We'll start off as the empty string. And then what we'll do is we will add onto file contents whatever it currently is concatenated with the next element. All right, and then in the end, I should be able to just print out file contents, which should be my program separated by semicolons. So there's my remember this, and then remember this. We have semicolons there. Okay, so what we've effectively done here is we've brought in each element of our file into a single string. Okay, brought it into a single string. Now that single string can now be broken up into parts. So we're going to say we're going to have a string array called the program statements. Let's call it the program lines here. And this will be equal to file contents dot split on a semicolon. Because every line has a semicolon in it. And then what I'll go ahead and do is I'm just going to prove that we got all these. So I'll say for int I is equal to 0, I is less than the program lines dot length, I plus plus, and we'll go ahead and we will print out the program lines at bucket I, hopefully seeing that it's now split into those individual strings. So there's bucket 0, there's bucket 1. So it split my string into those pieces. And if you want to see what that looked before, I just had it up there, but we'll put it back in. This is the before and after. So after I built up my file contents, I have a string that looks like that. Then I went ahead and split that string on the semicolons, which left me with an array with 2 strings in it. That string at bucket 0, that string at bucket 1. And this is something that our parser can now deal with. So what do we want to do? For each of those lines, we want to so this was proving the lines. So for each of those lines, we want to call parse statement. Because each one of those lines is a statement. So after we've parsed the lines, we'll go ahead and call parse statement in each of those lines. What does parse statement do? It parses it. It tries to determine which kind of statement it is. Right now, we only have remember statements. And then what does it do with that remember statement? It adds it to my list of statements. So now I should be able to parse the contents of my input.spider file, and parse will go in, like we just said. It'll go in, it'll read in every line from that file, building up a single string with the contents of the entire file. Then it'll split that string up on semicolons, giving us the individual lines of our file, but not requiring us to put them all on one line. I'll show you what I mean by that in a second. Then it's going to go through, and for each of those statements, it'll call parse statement. And parse statement will go through and it'll say, oh, what kind of statement are you? It'll determine that they're both remember statements, because that's all our language currently supports. And it will add them. So it'll call parse remember, and then it'll add those guys to our list of statements. So what we should have now when we run this is we should have 2, when we call parser.display, we should have 2 remember statements stored in there. So there's our remember statement in equals 5 and our remember statement in b equals 7. So those guys have now been converted from our language into an intermediate language. And what I meant a minute ago is I can do this now. I can put my entire program on one line if I really want to. Not that that's not human readable, but now my parser can handle that, because it doesn't presume that I pressed enter or anything like that at the end of lines. So I still get my same contents. All right, so let's pause for a second here. We've written quite a bit of stuff here. So what questions do we have about what I have written so far?
Yeah, can you please explain the super keyword that you used in the remember statements again, please?
So remember, we have this thing called statement. And well, here, let me show you the picture first. So we created this hierarchy where we created a simple class called statement. And then underneath that class, we created subclasses. For instance, the only one we have so far is called remember statement. I'm also going to have a resolve statement. That's going to actually be what your homework assignment is. So we have a top level class, and then we have subclasses under those, which are specialized versions of generic statements. So in my code here, I wrote statement, and statement has a statement type. He has a constructor that takes in a single string, which is a statement type, and sets the statement type. And then he also has his own toString method that can be used in conjunction with system.out.println for printing stuff out. All right, but when we look at statement here, we're going to say this guy is pretty simple. But now when we go to create a remember statement, this guy, remember statement, is being built in terms of a statement. So his parent is an instance of statement. And the way that we reference the parent in C++ based object-oriented languages like Java is we refer to our parent as super. So the super keyword is our parent. So for remember statements perspective, when we say super here, we're saying I want to call my parent's constructor first. So I'm implementing remember statements constructor, but the very first thing we're going to do is call our parent's constructor to do any initial setup. And because we're building a remember statement here, our parent's constructor, which you remember here in statement, takes in a single string as a parameter. And that string then gets set to the the field that statements are keeping track of, which we're only using right now for a certain purpose. You'll see later. Right? This is more of a setup for what we're going to see later on. It will be helpful to have this, but in any case, that statement type is more of a reminder for us of what we're actually accomplishing here. But punchline for us is this is the constructor for statement. If I'm inside of remember statement and I want to call upon my parent's constructor, I put that. Super is my parent. So I want to call my parent's constructor, passing it whatever it requires, which in this case is the string. And then I'll do some extra stuff that makes me different from my parent. Similarly, down here, when I'm calling toString, I didn't have to use my parent's string here. If I took that out and I run my program, notice I just don't get the output from the parent constructor or the parent toString. When I put that back in, I'm saying, you know what? I want my parent to go ahead and give me his version of toString, and then I'll add some extra crap onto that for my version of toString. And that's where the parent says, ha, I'm a statement of a remember statement. And then the child says, specifically, this is what I'm remembering. Parent, I am specifically a remember statement. Child, this is specifically what I'm remembering. So it's just a visual thing, but that's how that super keyword is being used. It's how an object refers to his parent from within himself. So if you want me to add that to a slide here. This is how an object refers to himself from within himself. Super is how an object refers to his parent from within himself. Those two keywords are related. One is how do I talk about myself? The other one is how do I talk about my parent? Does that make some sense?
Yeah.
Okay. So, any other questions about what we've done so far before I give us our setup for our homework?
I know it's not an immediate question, but how the variable environment would be put into practice?
That's going to be this piece right here. The interpreter that's going to take our intermediate objects and actually turn it into real stuff, where we actually create a variable named A and store it in our environment. We actually create a variable named B and store it in our environment. Right now, we're just getting close to the point where we can do that. All right, so let's go this route. So when we think about the current abilities for our homework for today, we wrote variable environment, right? And variable environments had two abilities. We had the ability to add a variable. We also have another ability to get a value. All right, both of those things. So now with that in mind, what we want to be able to do is we want to be able to parse our syntax for both seeing a value, or storing a value rather, and then also seeing that value. So what we're going to do is we're going to have two new statements. But initially, we'll just have one new statement for the homework assignment. So we're going to have a statement called a resolve statement. So if we go back to our language here, we're going to add a syntax to our language called resolve. And my intention is to keep these lowercase. Var name. I'll give examples here of these. Remember a equals int a equals 5. And then similarly, we'll say resolve a. Okay, so now we're adding a second type of statement to our language called a resolve statement. Okay, and we look at the code here, I'll kind of walk you through what we've done so far. So when we added our remember statement, what did we do? We created an object for remember statements that were built in terms of a generic statement. They remembered the three pieces of information about a remember statement. We gave them a toString, that way we can prove that they worked. And then we gave them some getters for their individual values. Inside the parser, when we parsed a statement, we determined what kind of statement are we parsing. Okay, so for us now, we're going to have an else if the parts at bucket 0 dot equals resolve. If we're looking at a resolve statement, write the necessary code to parse the resolve statement into a resolve statement object. All right, so just like we've already done this for remember, you have to now make it work for resolve and create the correct kind of objects for this guy. So the homework assignment is to add, let's see, homework, add a resolve statement to our language and upgrade parser so he can parse statements of this type and add them to our list of statements. All right, and what this ultimately means is that I should be able to then write in my syntax here, resolve A, resolve B. And it will parse these guys correctly, giving me now a new type of statement that gets stored inside of my list of statements in the parser. Let me grab this here. And I'll update my repository here in a second. And this will be due on Wednesday. So pretty similar to the assignment for today. You saw at the beginning how quick it was to write. I know that some of you might be struggling with it, but this gives you some more time to get your programming skills up. This assignment shouldn't take any more than maybe 10 minutes, 15 minutes. You're going to create an object, ask a couple of if statements, and add something to an array list. But you'll basically do the same pattern that we did today, where we created the object, we created the entry into the parser. So you're just going to do what we did today, but for one new kind of statement. So I realize that some of you are going to end up spending 3 or 4 hours on this, and that's okay. But that's to give you practice, because you're able to just do what I did today. So maybe you walk through the lecture and you add to your current solution for the homework what we did in class today and get that working, make sure you understand that. Then you should have the competency to add the next step to it, which is what the actual homework is for next class. And I want you to submit a GitHub link and the self-assessment. All right, and like I said, I haven't looked at the assignments due today yet. I'll look at them sometime today, but depending on what they look like, if I'm assuming that several of you struggled with the assignment for today, what I don't expect is for you to not ask any questions between the class on Thursday and the class on Tuesday, and then come and ask me, oh, how does something work? Because you're going to lose the points on the homework assignment is the punchline. So the point of doing homework is to learn. When I do something in class, you're seeing it done relatively quickly, relatively error-free. And I get that that's not where most of you are going to be yet, and that's fine. That's why you now have time to go home and practice. Repeat what I just did in class. Make sure you've wrapped your mind around it, that kind of stuff. That way you're actually learning something. And you're learning it at your pace, not at my pace. So before I forget, let's go into my repository here. So we've made some changes for today. So changes leading to, actually, let's just say, added support for remember statements and parser. And we'll go ahead and commit that to main and push that. And then let's make sure that it is up to date. Yep, here's our input file. Here's all our objects we wrote today. So you should have now a up-to-date version of our code for your homework due on Wednesday. And Wednesday we'll plan on being in the classroom, because on Wednesday we have the better classroom that has the reasonable Wi-Fi, the 2 TVs that I can reasonably project the screen onto and stuff like that. All right, questions about anything?
I have a question.
Sure.
So when I tried to clone from the github.com last time and then tried to run it in the sclip, but it gives me an error when I'm trying to running the code that the file is missing. So do we have to create like,
You don't want to clone it. Well, you want to fork it first, then you want to clone it.
right?
So, I mean, I don't know what the error of the file missing thing is. You Google that probably, or if you're having significant issues, you could just, create your own objects and copy them in, create your own project and just copy the files in so you have it working. You could do that as well if that's easier.
So you mean that like just create the new repository?
You can create a brand new project and then just copy these .java files into it. You shouldn't have to do that. So I would start off by just Googling whatever error message you're getting. Maybe you're doing something weird in how you're cloning it and then how you're importing it into, because probably what you want to do is inside of Eclipse, you want to say import existing projects into workspace. And then you want to go wherever you're cloned your repository, your desktop or whatever. That's what you want to bring in there, because this should be the full repository. Let me just go back into here. Yeah, so I've given you source. It might be complaining that you don't have a bin folder. I think it creates it for you though. But that's the only thing I see missing here. From the project, there should be a bin folder, but since it gets deleted after it's run the project, I don't think it's necessary. I'm just kind of giving you a suggestion that if it's complaining that it's missing a folder called BIN, you could just create a blank folder in here called BIN, and then it should work.
So I have to create the new class into the S-clip called BIN.
And it's not a new class, it's just a folder. So, I mean, I would say forget about what I just said about BIN. I'm trying to give you suggestions on how you could fix it. I would start off by just searching for whatever the error message is on Google.
So can you explain what you were saying about the S-clip, like how to import the file? Like let's say if I download it under the my download.
So inside of Eclipse here, so after you've downloaded you have the folder on your computer somewhere of your forked code of my code, right?
Right.
Okay. So then you'll come in here and you'll right click and you'll say import. And then you'll choose existing projects in the workspace. And then you go browse for wherever you put it. Maybe you
Download.
Desktop or something like that, downloads, wherever it is. You'll find that folder. You'll just click the folder.
Can it be fully sleep?
What?
No.
And then if I click on that folder, it's showing me there is another folder inside of that, like source file, and there are like 5 or 6 different inside of that.
The folder. The folder itself is what you're opening.
Like the whole folder called source.
Yep.
Okay.
I think it's above source because the folder itself. Let's see. Do I have it in here? Here's my repos. The folder itself has 2 folders in it. So this is what you're opening, this guy.
Okay.
That's the project you're importing.
Okay. Thanks.
All right, so homework is up. I will see everybody at 10 a.m. on Wednesday.
Can you share the keynotes to people, to us?
Is it? It's not shared?
At least I don't know if there is a URL.
Wait, hold on. 1 second. 549. Okay. Copy link. And add a web link. Course slides. So you should have a link now on Blackboard called Course Slides that if you click, it'll open up your
Thank you.
slides.
You'll share the new room details in Slack.
What's up?
Uh, will you share the new room details on the Slack classroom details for Wednesday?
Well, the room is here. Zoom classroom, is that what you're talking about?
Yeah.
It's on Blackboard.
No, not for Zoom. The in-person classroom.
Oh, it's not a new classroom. It's the same room we were in the other day. It was here. I'll put it up there. But it's
Okay.
the room we were in on last Wednesday, S109. The big room that was across the hall. The little room we were originally in with all the echoing and stuff.
Okay, sure. Yeah.
So this is the good room that has all the connections and Wi-Fi should be reasonable in there and that stuff. But we were in the same room last Wednesday.
No, thank you.
All right, I'll see everybody on Wednesday.